Okay, in the last video, we looked at how to find atomic mass, basically looking at how to find the mass of one atom. So this video, we want to look at what's called molecular mass, and this is how to find the mass of one molecule of a compound in AMU or in grams. Because remember, we deal with atoms some, but a lot of times when you're looking at chemical formulas, chemical equations, and reactions, you're dealing with compounds like water or salt or something else. And so we need to know how to find the mass of those. And we want to be able to find it in AMU or in grams. As a reminder, our conversion is that 1.66 times 10 to the negative 24th grams is the same thing as 1 AMU. Okay, and remember the AMU is the atomic mass unit, and it's really only useful when you're looking at problems like this, when you're trying to find the mass of just one atom or one molecule. In the next video, you're going to find out we rarely just deal with one atom or one molecule because that is tiny, tiny, tiny scale. So we'll talk about kind of what to do in real world type situations. But for now, we're just looking at just the one. Okay, so for instance, if I had water, H2O, and I wanted to find its mass in AMU or in grams, what we're going to do is add up the mass of everything in water. Okay, if it helps you, you can make a little chart. All right, first list your elements that you have in the compound. Well, we have H and we have O. Then list how many of each you have. Well, we have 2 H's and 1 O. Then you want to multiply how many you have, that's an X, by their AMU mass on the periodic table. So if we go look up at H, it's 1.01. So I'm going to put 1.01 here. If I go look at oxygen, it's 16, so that means it's 16 AMU. Okay, so up here, this is 2.02. This is 16.0. We're going to add them together to get our total mass of the whole thing. So total, it's 18.02 AMU. And really, okay, I'm not super picky on this one, but in terms of sig figs, when I add or subtract, I can only go as far as my last or my most precise sig fig. So since this one only has 1 decimal, I should only have 1 decimal. So really just 18.0 would be your best answer there. Okay, and that's in AMU, but I said let's do it at AMU or in grams. So now we're going to convert 18.0 AMU, and we're going to convert that to grams. So the 1.00 AMU goes on the bottom to cancel, and the 1.66 times 10 to the negative 24th grams goes on top, and I'm going to enter that in my calculator. 18 times 1.66 EE to the negative 24. I get 2.988. Oops, sorry, zoomed in there. 2.988. I really need 3 sig figs, so 2. There we go. Sorry, my awesome camera skills here. I'm sure I'm impressing you. Okay, so I'm going to put 2.99 times 10 to the negative 23rd grams. Okay, so a molecule, one single molecule of water weighs either 18 AMU or 2.99 times 10 to the negative 23rd grams. Okay, let's try another one. What if I said calcium nitrate? Remember when I told you in Apologia everything builds? Okay, everything builds in chemistry. This is why you have to be able to write chemical formulas. All right, because if you can't write this formula, you're going to get this math wrong. Okay, so please make sure that you have memorized the polyatomic ions, that you know what nitrate is. Please make sure you understand how to cancel your charges out to get them to 0. All right, because on a test, if you can't write this formula, then you're going to get the math wrong. Okay, and we're about to put more math on top of it. So please, 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 if you didn't understand how to write formulas, you need to go back and learn those before you add math. Okay, so let's just review. Calcium is Ca plus 2 because it's in group 2 of the periodic table. Nitrate is NO3 with a -1 charge because I have that memorized, polyatomic ion. These charges don't add up to 0, so I can drop and swap those numbers or crisscross to get my answer. So Ca, and since I need 2 NO3s, I need to put parentheses around my NO3 and stick a 2 on the outside. Now I'm ready to do my math. Again, I would suggest making your chart. Okay, so we have calcium, Ca. we have N, and how many N's do I have? Don't just write 1, because remember this 2 goes with the NO3. So I have 1 calcium. For N, I have 2. And for O, don't write 3, because I have 2 sets of 3, so I actually have 6. Then go to the periodic table and look up all of their atomic masses in AMU, because that's what we're going to start with. So calcium is 40.1. Nitrogen is 14.0. And oxygen is 16.0. So now I'm going to multiply those numbers to get all my totals, and then I'm going to add them up. So obviously the top one is just 40.1. 14 times 2 is 28.0. And 16 times 6 is 96. Okay, and then I'm going to add all those numbers up. So 40.1, except I didn't put it in my calculator, 40.1 plus 28 plus 96 gives me 164.1 AMU. So, calcium nitrate weighs 164 AMU, 164.1 AMU for one single molecule of it. Okay, and if I want to change that number to grams, then I would say 164.1 AMU times 1.66 times 10 to the negative 24th grams over 1 AMU. So that way my AMUs cancel. And then enter that in my calculator. Okay, I got 2.74 times 10 to the negative 22nd. I probably need 3 sig figs here because of this 1.66. That is a measuring number. And so we're going to say 2.72 times 10 to the negative 22nd grams. Okay, so one single molecule of CaNO32, I can say it weighs 164.1 AMU, or 2.72 times 10 to the negative 22nd grams. Both of those would be correct. Remember, I want to remind you, this is talking about just one of these. Think about how small one of those would be, and how really impractical that would be to use in a lab setting. We can't ever get just one of those. Okay, that would be smaller than like the tip of my pen or my pencil. So the next video is going to introduce you to a concept called the mole, which is going to prepare you for how we really deal with this kind of math in a lab setting or more in real life, because normally you don't just find the mass of one of these. Alright, but Apologia likes for you to know, so this is how you do it, and then we'll move into the mole concept, which is much more practical and more widely used than this. Alright.